Last Christmas, I was lucky enough to go and visit some friends in Australia. When I was packing, I realised I'd bought them far too many bulky and heavy Christmas presents, and that I'd have to leave some behind. I decided to pack the combination of presents that would be highest in value to my friends, but that didn't exceed the weight limit imposed by the airline. But how could I decide which ones to pack? As I'm a mathematician, I thought about trying all possible combinations, calculating their value and weight, and picking the combination that was below the weight limit but maximised the value. But there were simply too many combinations to try out, and I was worried I'd take so long I'd miss the plane. So in the end, I just paid for an extra bag of luggage. This problem is a lot like the optimisation questions in the higher maths course, but there are no easy fixes like paying for more baggage allowance. Let me show you what I mean. This is Think 4. Higher course optimisation questions can be to do with area and volume, but they can have other contexts too. Often when you get questions about boxes or trays, you want to either maximise the volume or minimise the surface area. Optimisation questions tend to be split into parts A and B, and many students avoid the part A, losing up to 3 marks. To master this part of the question, you need to have a clear strategy. Here is a part A question about an open tray with volume 1,800 centimetre cubed. We have to show that the area is equal to 2x squared plus 5,400 over x. We need to form 2 expressions, one for area and one for volume, using our knowledge from the Nat 4 and Nat 5 maths courses. Here, volume is equal to 2x squared h, and area is equal to 2x squared plus 6xh. The area expression we need to get to has no h in it, so we rearrange the volume formula to make h the subject, giving h equals 900 over x squared, and then we substitute it into the area expression to get the area formula required by the question. There is usually a fair bit of algebraic manipulation involved, so be careful. You should practice these part A questions and try not to avoid them. There's usually a part B asking you to find the minimum or maximum. In these part Bs, you're just solving a stationary points question, but it's in a context, so often the notation is different from using y and x. You will differentiate, equate to 0, and solve. However, because this is an optimization question and you're asked to find a maximum or minimum, it's important you prove the nature of your stationary point with a nature table or second derivative test. The SQA marking instructions from the 2018 Paper 2 Question 9 give excellent examples of nature tables that are okay and ones that are not acceptable. It's also important to relate the answers back to the context of the question. Does it need units? And do you need to reject a negative solution as it makes no sense in the context of the question? Your answers for optimization questions should be as full as possible, with words relating your answers back to the question context. Optimization questions can be worth a lot of marks and tend to follow a similar structure. Try practicing 3 or 4 in a row and have a look at where the marks are allocated using the marking instructions. This will help ensure that you're including everything you need to. And when it comes to delivering presents to the other side of the world, my advice is simple. Perhaps don't be so generous, and remember to buy smaller and lighter gifts. This was Think 4. Thanks for watching.